CD and GH are respectively bisector of angle ACP and EGF, such that D and H lies on the side. Okay, as usual, the question is not clear. We need to draw something to make it clear, right? So let's draw. So we have triangles ABC and EFG. So I begin with that. A bit weird triangle I'll draw. It's for better visualization, that's all. Okay, now because they're talking about angular bisectors, so I drew this. It's bisecting at C and G. Okay, I'll make them as C and G. So this has to be C, and for me, that has to be G, right? Then they're given if triangle ABC, okay, so let me call this as ABC, is similar to FEG. So this is where many people get confused. The order has to be same. A has to match F, B has to match E, and C has to match G. Okay, well and good. And now we're talking about angular bisectors. So we have this angle and it's getting bisected. What does it mean? It means that this line divides the angle into two equal parts. Again, don't worry about, right? Don't worry about the side being bisected. If it's not, it's okay. Angular bisector bisects angle, not the sides. If it's not bisecting the side, means it's not meant to. It's as simple as that. Many people get confused between bisecting bisector of angle and bisector of side. Right? It's very clear that it's bisecting the angles. Okay. Who are bisecting the angles? CD is bisecting angle ACB and GH is bisecting EGF. So let's read the question now, if it makes sense. It's okay to draw the diagram and not be right. You scratch it and redo it again. Yes, I get to erase it, but it's okay to scratch and it's okay. It's always okay to draw and not have the diagram right. But yeah, reread so that it's confirmed. CD and GH are bisectors of angle ACB and EGF. Okay, okay, and yeah, right. I'm reading as if I'm looking at the diagram for the first time. Such that D and H lie on AB. D is on AB and F. Right, it's correct. Of triangle. Okay, these two triangles respectively correct. And it's given that ABC is similar to triangle FEG. Okay, done. So we are done with that. Now it's given. See, whenever you get such information, it's important to write given because in given, we'll expand the information. That is, since these two triangles are similar, AB by FE will be equal to BC by EG, right? I'll show it to you with color code. EB by FE is equal to BC by EG, which will be equal to not B, AC by FG. And angle A is equal to angle F, angle B is equal to angle E, and angle C is equal to angle G. But yeah, wait. This angle at angle C and angle G, there are three arms, so it's better to expand and write. So let me rewrite this. Angle BCA is equal to angle EGF. Okay. So this is the first part of the given. There is another part, that is CD is bisecting this. So before that, I'll call this as equation 1, equation 2, right? Similarity can be proved with angle over here. You can clearly see there's nothing given about sides, so it will be difficult. It's always easier to handle with angles. Now, they're given that this CD is a bisector of this particular angle and HG is a bisector of this particular angle. Let's make use of that. As CD bisects angle BCA, therefore, what can we conclude? We can conclude that angle BCD is equal to angle TCA, which is half of angle BCA by 2, right? BCA by 2 is half of, it's the half, right? That's what bisection means. We'll call this as 4. All of this will be useful as GH bisects angle EGF. Therefore, angle EGH is equal to angle HGF is equal to angle EGF by 2. This is your angle, this is your phi, equation phi. Okay. So now let's dive into the question. So they're talking about ratios, then they're talking about similarity. It's easier to prove the similarity than the ratios. So first we'll go with the second question. DCP is similar to HGE. It's quite simple, right? Because we already know that angle B is equal to angle E and angle A is equal to angle F and angle C is equal to angle G. We already know that. So plus we know that this is equal to this, right? And this is equal to this. So by default, we have two angles and we are done. So now is the part of writing. So how do you write all of this? It's easier to look and tell, okay, they are similar, but how do you write it? So we are looking at answering the second question. Consider triangle DCB and triangle HPE. So we have angle B is equal to angle E. This is from equation 2. This is from 2. Then we have angle DCB is equal to angle HCE. This is it's kind of a bit of a long stretch. So how do you do this? Okay, let us write that. Let's write angle. Equation 3 dividing 2 divided by 2 will give us BCA by 2 being equal to angle EGF by 2. So we know that half of that is nothing but you have BCD being equal to half of BCA. So we can tell, therefore, BCD is equal to, and half of EGF, I can write it as EGH, angle EGH, right? And so we have this to be our, which equation? Equation 3, I guess. No, you need not call it as any equation. So therefore, by AA similarity criteria, triangle DCB is similar to triangle HCE. The second question is proved. Similarly, the third question also. The ratio part, we can do it later, not an issue. Because once the triangles are proven to be similar, then ratio won't be that difficult. Consider, now the difficult part is moving up and down. It's triangle TCA and HGF, right? That's what they're talking about. TCA and triangle HGF, right? So here to, which is on the top, angle A is equal to angle F, right? So this is equation, I think 1, hopefully I'm right. Then same thing, equation 3 divided by 2, which gives me angle BCA by 2 being equal to angle EGF by 2, right? So half of BCA is DCA. Angle DCA is equal to angle HCF, right? So basically, these two triangles are equal. This is from 5 basically, but we already written the reasons and stuff, so we can just continue. You can tell from 4 and 5. Okay, here too we can tell. Where is it? Here, from 4 comma 5. So everything is linked, proper. So presentation is the key over here because it's kind of lengthy and confusing for many. So by AA similarity criteria, we have triangle DCA being similar to triangle HGE. Oh, sorry, HGF. We are done with that. So then at last we have CD by GH being equal to AC by FG. Therefore, first question, as triangle DCA is similar to triangle HGF, right? That's what these two ratios, this pair of ratios are in this triangle. I noticed that. So I'm taking this two triangles. Since they are already similar, I just have to write the ratios. DC by HG is equal to DA by HF, which is equal to CA by GF. Hence proved. Okay. So you can have a pause and look at the answer.